the electronic basis for the periodic law and the periodic table. After the discovery of the periodic law and the periodic table, for quite some years, scientists didn't understand why there is such a law and a table. However, once the electron arrangement within atoms were clear, everything was explained. The electron arrangement in the outermost shell is the same for all the elements in the same column. Remember, we have concluded that the electrons in the outermost shell are troublemakers. The electrons in the outermost shell, they are the farthest away from the nucleus. They have the most freedom. They make the most trouble. They decide the chemical behavior of the element. So for the elements in the same column, they have the same number of electrons in their outermost shell. They have the same number of troublemakers. They make similar troubles for them. And that is why elements in the same group have similar chemical properties. Well, let's look at some the electron configuration of some of the elements in the same column. We're looking at elements from group 1A, and we listed 3 elements from period 2, 3, 4, lithium, sodium, potassium. As we can see, they all have 1 electrons in their outermost shell. If we go to group 2A, the element next to lithium will be beryllium. Beryllium will be the one right next to lithium, right after lithium in period 2. If we write out the electron configuration, the outermost shell will be 2s, 2 electrons here. And if we go to the next one after sodium, that will be magnesium. The electron in the outermost shell will be 3s, and it's going to have 2 electrons there. The next one after potassium in column 2A, that is calcium. The outermost shell of calcium will be 4s2. We can move down to 3A. Let's try to 3A. Okay. Elements in 3A. In period number 2, the element in 3A will be boron. The outermost shell is ictra shell number 2, and there will be 3 electrons in shell number 2. So it's going to be 2s2. 2s can only hold 2 electrons. The next electron, 3 electrons in the outermost shell. The next one will go to 2p, and 2p is going to hold 1. Okay. In period 3, column 3A, is going to be aluminum in 3A, and the outermost shell will be 3s2, 3p1, 3 electrons in their outermost shell. The next one below aluminum will be gallium, and the outermost shell will be 4s2, 4p1, again 3 electrons. All these elements in the same group, they have similar property because they have same number of troublemakers, same number of electrons in their outermost shell. And if we can keep going to 3A, 4A, 5A, but let's just go to 7A directly. These will be the electron configurations of 7A, and they all have 7 electrons in its outermost shell. Keep in mind the outermost shell in this case for bromine is shell number 4, and it includes 4s and 4p. Again, 7 electrons. 7 electrons. Okay, let's summarize from what we just went through for this electron configuration from elements in 1A, 2A, 3A, up to 7A. What we see is that column number, the Roman numerals in the column number, actually tells us the number of electrons in their outermost shell. Column 1A, they all have 1 electrons in their outermost shell. Column 2A, they all have 2 electrons in their outermost shell. Keep going. So the Roman for A group's element, this doesn't apply to B's. Okay, we focus on A's in this class. For the A group elements, the Roman numeral tells us the number of electrons in their outermost shell of all those elements in the column. Also, there's another fact we can see here. The period number, 2, 3, 4, the period number actually tells us how many electron shells does each of the elements in that period have. Okay. For period 2, lithium, outermost shell will be shell number 2. It has 2 electron shells. Beryllium is also in period 2, so 2. Boron in period 2, so outermost shell again is shell number 2. And period 4, potassium, calcium, gallium, then shell number 4 will be their outermost shell. Okay, column number tells us how many electrons. Well, again, I want to remind everyone we're talking about the A groups. In the A group elements, the Roman numeral 1 through 7 tells us the number of electrons in their outermost shell, and the period number, the position of the elements in the periodic table, the period number tells us how many shells are there for each element. Electrons in their outermost shell are filling the S subshell for column 1A and 2A, and are filling P subshells for 3A to 8A. All right, so we all know that for elements in column 1A, there are electron configuration of the outermost shell will be N-S1. I'm using N to represent the number of electron shells, which is also the outermost shell number. Okay? In the case of lithium, as we already saw on the last slide, lithium, the outermost shell will be 2s1, sodium will be 3s1, and potassium will be 4s1. That's what we saw on the last slide. If we understand that, for sure we will also understand the outermost shell electrons for the column 2A will be Ns2. You add one more electron to the S subshell. S subshell can hold up to 2. So that's what it said here. For column 1A and 2A, electrons are filling in the S subshell. What about another electron? What if there are 3 electrons in their outermost shell? Well, you cannot put anything into S anymore. S has 2 now, already fully filled. The next one will go to the P subshell. So starting from 3A, go to 8A, electrons will begin to fill in the P subshell. P can hold up to 6 electrons. That's why P has 6 columns here. All right, as summarized in the last column, in the last slide, we know that the first 2 columns, electrons are filling in S subshell. 6 columns here, electrons are filling in P subshells. So we call the first 2 columns in periodic table, we call it call them S area. This is called P area. As a matter of fact, if we dig into the electron configurations of all other elements, this area will be called D area. Electrons are filling in their D subshells, and this is F area. Electrons are filling in their F subshell. S can only hold 2 electrons, so S area has 2 columns. P can hold up to 6 electrons, so P area has 6 columns. D can hold up to 10, so D has 10 columns, and F can hold up to 14. F area has 14 columns. Suddenly, it all makes sense to us now. Based on the electronic basis, totally, if we construct our periodic table totally based on the electronic basis, this would be how a periodic table look like. So there will be F area right here, 14 columns. But it's going to make the periodic table too long. It is not very convenient to use. So people cut them out and put them here, list them out separately. Well, we just went through some of the electron configurations in periodic table. We realized that it is the last electron added to the element that makes the element's electron configuration different from the one preceding it. So it is the last electron added to the atom makes the element different from the one before it. So that electron is called the distinguishing electron. That's it for today.